Okay, lesson 17, we're looking at identifying the nature of functions. What's the learning goal? Basically, if I give you a table, equation, or graph, I want you to be able to tell me or classify whether the function's linear, quadratic, exponential, logarithmic, and degree of a polynomial if it is a polynomial. So I'm not going to waste too much time with this. Basically with the polynomials, and I'm going to start with the graphs and equations, so let's do both at the same time. So polynomials, we'll start with them, graphs, and equations. So we'll do this, combine these two, because these are these ones should be easy, they should be straightforward. So if you want to make a couple of grids for yourselves, they don't have to be very large. So we have linear, quadratic, cubic, we'll go up to degree 4. So if we look at the first one, linear, okay, the graph's going to be a line, so I'm hoping people can pick this off. So we have linear, and the equation is going to be degree 1. The exponent on the x will be a 1. So for example, 2x plus 3. All right, so we have a degree. We'll go exponent on x, it's 1. If it's quadratic, the exponent on the x is 2. The example, y equals x squared minus 1. Go down to exponent on x is 2. If it's cubic, it'll look like this. So if you see the S-curve shape, you know it's a cubic. So y equals x cubed minus 2, and the exponent on x is equal to 3. And finally, the quartic, you get that W shape or an M shape. So y equals x to the 4th plus 3. The exponent on x equals 4. Can I make it tricky? It is possible because I give it to you in factored form. So for example, underneath here, we'll just continue underneath each one. So even if you want to divide them into kind of some columns for yourself, keep it straight. So let's put an or, and I'll work in a different color here. What happens if I gave you x plus 2, x minus 1? For the cubic, y equals x minus 1, x minus 3, x plus 2, y equals x minus 1, x plus 1, x plus 2, x plus 3. Okay? In these cases, if I give them to you in factored form, for all of them, sum of exponents on factors equal 2. So you'd have 1 and 1, so 1 plus 1 is 2. Sum of exponents on factor equal 3. So 1 plus 1 plus 1 would give me a 3. And similarly, 1 plus 1 plus 1 plus 1, exponents of 4. So sum of exponents on factors, on factors equal 4. All right. So there you go. So that's graphical and equation. Exponential and logarithmic I'll do down here. We'll continue on. Exponential and logarithmic, or logs. Graphical and equation. Again, I think it's a fairly easy exercise. So if we look at our exponential, there are two options. So you could get an exponential that looks like that, a decreasing, or you could get one that looks like that, increasing. And your equation is going to be y equals some number. So let's go 5 to the exponent x. So exponent has the variable. So if you see that the exponent is in the variable, or sorry, the variable is in the exponent, then you have an exponential function. And then similarly with the logarithmic, this one looks like, all right, so we come up here, so it could look like that, or it could look like that. All right, so it approaches that the y-axis, and we talked about properties of logarithms. The equation y equals log base 2 of x. So hopefully this is fairly obvious on how you tell a logarithmic equation. I can't really hide it. Right? Log is in the equation. The hardest of the methods, or the different formats to present data, so we have graphs and equations here, so they're somewhat straightforward. So then we get to the tables, and that's what the next section is. So polynomials, how do you tell? I've got 4 tables here. How do you tell if we have a linear, quadratic, cubic, or quartic? It all comes down to first differences. Okay? So going back to grade 9, your first differences. If we look here, we have 3, 3, 3, 3, 3, 3. If the first differences in the first column are the same, you have linear. Okay? If I go to the second example, I have 2, 6, 10, 18, did I do this right? Better check here. Yeah, that's right. 32, so that's 8 and 18. Oh, not good when I have a brain cramp all of a sudden. So that should be 18. So that probably won't be 18 there. That's going to be 14. Hello, there we go. Back to work again. And this one here, 22, which doesn't seem right. Oh, that'll be fine. Okay, so the first differences apparently are the toughest part here, is calculating first differences. So what happens when you do this on a Monday morning. So anyway, they're not the same, so therefore it's not linear. So we know the first column's linear, so we know it fails that test, so it's not linear. So we do the next set of differences. So we have 4 here, 4 here, 4, 4, 4. If the second set of first differences, or second differences, are the same, then we have a quadratic relationship. So therefore, it's quadratic. Okay? And you start to see a pattern here. So here we have degree 1. So it's the first column. So degree 1. Here, it was the second differences. So now we have a degree 2. Moving along to the next example then. Let's see how the math goes with this one. So we have 1, 7, 19. That one's going to be 61. I've skipped one there. And the 216 minus the 125 be a 1 and 9. So need to get that out of there. If you make a mistake here, it kind of significantly changes your results. So hopefully I did that one right. Going to your second differences, so it's not linear. Now I have a 6. Take away 7, that's a 12. 37 minus the 19. It's 20. And 61 minus 37. 24. 91 minus 61 is 30. So if we go through here, I have a funny feeling I've messed something up. Minus 27, that's a 37. Oh, it should be 18. There we go. Like I said, if you make a mistake, it really throws it off. So it's not linear, because linear would have been the first differences. It's not quadratic, would have been the second differences. Going to our third differences, we see 6, 6, 6, 6. And our third degree is cubic. So this table is cubic. All right, so degree 3. Now, if you do the same for the next one, if it's the fourth one, it's quadratic. All right, so I'm not going to go through, and you see the pattern now. So if the first difference is the same, it's linear. Second difference is the same, it's quadratic. Third, it's cubic. Fourth, it's degree 4 or quartic. Fifth, it's degree 5, and quintic, and so on and so forth. So then looking at exponential and logarithmic, they're kind of unique here too. If you take first differences, you see that you end up with 2, 6, 27, take away, 27, take away your 9, it's 18, 81, take away 27, it's 54, 243, take away the 81, it's 162. Now when I look at this, the lower numbers are kind of easier to pick out. I see that if I multiply this by 3, I get 6. And if I multiply 6 by 3, I get 18. If I multiply 18 by 3, I get 54. And again, multiply by 3. So if your first differences are multiples, it is exponential. And then logarithmic, if you take a look right away here, I had to set it up this way because if I don't, I get decimals. So 1, 1, 1, 1. But if you look at here, we have times 10, times 10, times 10, times 10. So the x values are actually the multiples, and the y values are values of 1. It's the reverse of the exponential. So there are your patterns. That's how you differentiate. And like I said, the tables are the most challenging. So you're probably going to want to make sure that they are on your cheat sheet, or at least an explanation, and you're going to get some examples in handouts. So anyhow, that concludes Unit 2. The review is posted, and if you need any help, you know where to find me. Good luck.